Hello, hello. Good. Good. Maybe good morning for some of you since we're Zooming. Maybe good afternoon. Either way, welcome. So we will get started here. I'm going to share my screen and then let's just take a quick peek at the syllabus together just so that we're all on the same page about due dates and everything. I had it pulled up here. Yeah. Okay. So this week we're going to finish up chemistry and measurements. Sorry about that. We're going to finish up chemistry and measurements. We may start getting a little bit into chapter 3. I don't know. We'll see. But notice that Monday of next week we are not meeting for class. Okay, so that is Labor Day. So enjoy your time. Your first test is coming up. You will take it either the 20th to the 21st, which is like a span of Sunday to Monday, at any point within that range. But once you open it, you only have an hour and 15 minutes. Okay, so just put that on your radar that you do have a test coming up. And then what was the other thing I wanted to? Labs. So you will have 2 labs due on Sunday, all right? So even though we're not meeting on Monday, there are still labs due Sunday, but guess what? You don't have to wait until Sunday to do them, all right? You can do them anytime you want. And if you want, actually, you can even work on them. I would recommend working on them today. And then if you want to bump into me tomorrow during lab time, we can talk about it. Or, you know, really anytime that's like within normal hours, you can email me and we can chit chat about it, okay? And then mastering chemistry, check up on there, make sure you have your assignments up to date. Cool, okay. So let's open up our slides here. So we left off talking about conversions, conversion factors. Take a peek over here. Spark my memory. All right, King Henry died before drinking chocolate milk. Have we started conversion factor stuff yet? Dimensional analysis? Maybe no. Okay, again, sorry. All of my 3 classes that are all different all start very, very similar. In some classes we have started dimensional analysis, with some we have not. Does anyone know what the last thing we left off with was? Then, like what your last thing we were chatting about in notes. Let's see. Just a little confused when doing conversion factors in lab 2. Okay. Let's see. I think we left off at King Henry. Okay, King Henry. Okay, cool, cool. Thank you, thank you, thank you. Yeah, I was like, have we done conversion factors or not? Because if not, we definitely want to go over that. Just trying to find out in the slides. All right. So we're back here with prefixes. There we go. Okay. So yeah, we had left off prefixes, inequalities. Perfect. Okay, thank you, ladies. So yeah, we had talked about then King Henry died before drinking chocolate milk and how this is a really convenient way to kind of hop around within the metric system. It's not always going to be that convenient, especially if we're going between metric and British. So that's where this whole conversion factor shenanigans comes into play. So let's use the slides here for a point of reference, just so we make sure we get through everything. So prefixes and equalities. So the prefix we can swap out to make a bigger or smaller unit. And then those prefixes will relate directly to like the base unit. So for instance, here I've got a kilometer or a kilometer. 1 kilometer equals 1,000 meters. Same thing if we were to switch out meter with liter. A kiloliter equals 1,000 liters, and a kilogram equals 1,000 grams. So that's the beauty, is that we can just sort of like Lego plug these different things in. If we go back to here, let's say I wanted to do a centi. So a centimeter, 1 centimeter is equal to 0.00 meters, all right, or 10 to the negative 2 meters. Let me put a 1 there, sorry, 0.001, yeah. I don't always like decimals, so sometimes you may see me say, hey, 1 meter is equal to 100 centimeters. I just divided this side by 0.01 and divided this side by 0.001, and it would give me 100 as well, okay? So we like prefixes, we like the metric system. At least it makes me happy. So this word equality. So when we're talking about equalities or conversion factors, what we're saying is two things with different units, but that are essentially saying the same thing, right? So a kilometer or 1,000 meters. You could say the same distance in either way. You could say, hey, I ran a kilometer, or you could say, hey, I ran 1,000 meters. So just for your information, the U.S. Drug and Food and Drug Administration uses metric prefixes to express the amount of daily nutrients required. So if it says protein, we don't give protein in a measurement of pounds, we give it in a measurement of grams. So yeah, so we can see all these protein. We need actually quite a bit of protein, right? 44 grams. These micronutrients, sometimes they're called, like vitamin C, vitamin B, calcium, these are all in the milligram amount. So this is a magnitude of a thousandth of the gram unit. All right, so let's fill these in with the correct prefix. So you need to write the prefix letter that equals that. So I'll do the first one. 1,000 meters equals 1 what? Well, 1,000 meters equals 1 kilometer or kilometer. Okay. So you can try this one and try this one. Okay, so for this one here, we have 1 times 10 to the negative 3, and that's just scientific notation for 0.00 1, 2, 3, yeah, 0.001 gram. So what is this would be 10th, 100th, 1,000th. What is 1,000th of a gram? It's a milligram. 0.01 meter. This isn't written in scientific notation, it's just written as the decimal form. This is the 10th place, this is the 100th place. So what's a 100th of a meter? It would be a centimeter. Right? Other ways we could write these two, if we wanted to sort of avoid that decimal, is to say for this one here, 1 gram equals 1,000 milligrams. This one here would be 1 meter equals 100 centimeters. So both of those can work as equalities. I tend to like these ones better just because I don't like decimals if I don't have to have them. All right, I'm gonna clear this out. Okay, so kilo, milli, centi. Measuring length. So measuring your eye retina, you'd use centimeters. Measuring the length of a nerve, you'd use millimeters. Here are some relationships. So 1 meter is 100 centimeters. 1 meter is 1,000 millimeters. 1 centimeter is 10 millimeters, right? Again, a lot of these are easy to convert between if we use King Henry died before drinking chocolate milk. So length, the metric length of 1 meter is the same as 10 decimeters, 100 centimeters, or 1,000 millimeters. So if I take this meter stick and if I divide it into 10 chunks, one of those 10 chunks would be a decimeter. If I took the same meter stick and I cut it into 100 little pieces, 1/100th of that would be a centimeter. And then if I was to cut it into teeny tiny thousandths, 1,000th of this would be a millimeter. So you'd expect to get 1,000 pieces of millimeters within each meter. Volume. So for volume, we use the liter as our base unit. We can see that 1 liter equals 10 deciliters. 1 liter equals 1,000 milliliters. This is really this guy here. Ooh, sorry about that. This guy here we use a lot, converting between liters and milliliters, right? Again, though, you can use King Henry died before drinking chocolate milk to hop back and forth between those. So this is one way of measuring volume using liters. Another way is to use it from a derived unit, or to think of volume as like a length times a width times a height. So if I had a square, I could calculate the volume of the square, length, width, height. One example of a volume using this is the cubic centimeter. So we'd write centimeter and then we put a little cube or a little third power of 3 on the top. What that is saying is when we have centimeter to the third, so centimeter to the third is the same thing as saying centimeter times centimeter, or a length times a width times a height, okay? Sometimes it's referred to as a cc. So a lot of you who are going into the medical field, when you hear, give the patient or the pet or whatever 50 cc's, they're talking about a centimeter cubed. This is super useful here. You want to remember that centimeter cubed is the same thing as a cc and is the same thing as a milliliter. How convenient. So 1 to 1 to 1. So if I say, hey, I have 55 centimeters cubed, you real easy can just say, well, that equals 55 milliliters. Okay, those two things are interchangeable. We like that. We like conversions that are easy. Okay, so here's an image of showing a cubic centimeter. If we were to have like a box, and this is a decimeter cubed, so it's a decimeter by a decimeter by a decimeter, or 10 centimeters, 10 centimeters, 10 centimeters. A centimeter cubed would just be one of those squares. It'd be a centimeter by a centimeter by a centimeter. We know again that this is equal to 1 milliliter. And if this is a liquid, right, it can fill up a syringe. So the syringe will have marks on it that say milliliters or cc's on it, and that's what they're talking about. How much volume do you have? So as far as mass is concerned, we will use grams. So again, this should sort of start to feel redundant, right? 1 kilogram should have 1,000 grams in it. 1 gram will have 1,000 milligrams. 1 gram has 100 centigrams. 1 milligram is equivalent to 1,000 micrograms. A microgram, or this little sort of mu symbol, is 10 to the third smaller than a milligram, or 1,000 times smaller than a milligram. You guys may see microgram pop up, so kind of be comfortable with that. Okay, so looking at these two, let's identify which unit is larger. So we'll just kind of go through it together. But A, we've got a millimeter or a centimeter. Which unit is expressing a larger unit? We're going to go with the centimeter. Right? If we think King Henry died before drinking chocolate milk, centimeter is closer to the king side. A kilogram or a centigram? Oh, definitely a kilogram. That's like a 10 to the 5 times bigger than the centigram. A milliliter or a microliter? The milliliter is the bigger unit. Microliter isn't within your King Henry died before chocolate milk. It's on the outside of it. It's even smaller than your milk. And then we've got a kiloliter or a microliter. And again, the kiloliter is going to be bigger. Okay. But all bigger and smaller by a factor of 10, 100, 1,000, so on. Okay, so let's talk about conversion factors now. Because I feel like most of the first half of this class when we're doing Gen Chem stuff is really just glorified conversion factors. We just do conversion factors. So in the United States, the contents of many packaged foods are listed in both US and metrics. So here we can see this has a net weight of 5 ounces or 142 grams. So those two things are equal to each other as far as the material that's in this. So if I was to write a conversion factor, I could say 5 ounces equal to 142 grams. So here are some of our equalities. How many equalities and or conversion factors are there in the world? Like, is millions. You won't really have to have any of them memorized because you are able to use your text and your notes for your exams. So you don't have to have them memorized, but you do need to be able to use them properly. So how we classify inequality, we use 2 different units to describe the same measured amount. Are written for relationships between units of the metric system, US units, or between metric and US. So here's a metric to metric. 1 meter equals 1,000 millimeters. Okay. 1 pound equals 16 ounces. This is between British, or US. And then we've got 2.2 pounds is equal to 1 kilogram. This would be sort of transitioning from the British or US system into the metric system. All right. These are just 3 examples of conversion factors or equalities. I mean the same thing when I'm talking about that. There are plenty out there. So any equality can be written as a fraction called a conversion factor. So I can take, for instance, this conversion factor of 60 minutes equals 1 hour. And I can write it 2 different ways. I can put it as 60 minutes over 1 hour or per 1 hour, or I can write it as 1 hour over 60 minutes. Either way is acceptable. Now, which one you're going to use within problems is going to be based off the setup of the problem, and we'll talk about that. Know that both of these things equal 1, right? An hour and 60 minutes is the same thing. So when we divide the same thing by itself, it gives us a value of 1. So anytime we're multiplying by a conversion factor, we're not changing the magnitude of the number, we're just shifting its units. Here's another example. We've got our equality here, and we can write a conversion factor where we put the 100 centimeters on top and the meter on the bottom, or the meter on top and the 100 centimeters on the bottom. Either or is acceptable. Which one you use depends on the problem. So important thing to note though, the 100 is glued to that centimeter. So we keep that as a packet, okay? We don't want to end up putting the 100 centimeter down with the meter and saying something like, hey, 1 centimeter is equal to 100 meters. That is not true at all. All right, so keep those values clicked together, just like this 60, it's going to stick with the minutes, right? 60 minutes, 60 minutes. We don't change that. So know this, that any equality between two metric units or between two US systems are obtained by definition and they're exact numbers, okay? An exact number does not, you do not have to use the significant figures for it, or your conversion factor is never gonna limit your number of sig figs. So if your given piece of information has like 3 sig figs, and then your conversion factor like this, for instance, 1 inch equals 2.54 centimeters, we're not gonna have our final answer be round to 1 sig fig. We're assuming that this here is an infinite number of sig figs. It's a definition, it's precise. We always go with the given information on that. So here's some equalities. There's a bunch. Your textbook will have them. The internet, you can type up, conversion sheet. The internet will have them, all sorts of different ones. But this one's nice because it separates them into length, volume, mass, and then you've got hidden underneath here time, which you probably know the time ones already. So again, taking inequality and writing it as a conversion factor. So 2 options, centimeter on top or centimeter on bottom. Here, we can put the pound on top or the pound on the bottom. Okay, so I want you to write conversion factors for the equality for each of these. Liters to milliliters, meters to inches. B, you may have to look up online on your cell phone real quick. And C is meters to kilometers. Okay. So is the conversion all three formats, or just pick one to choose? I mean, you can just pick one if you want, but I want you to be comfortable with like that they're all saying the same thing and that you might have to use different ones. Okay, so I'll write all three of them. So liters to milliliters. So I know that 1 liter is equal to 1,000 milliliters. And if I wrote these as conversion factors, I could say 1 liter over 1,000 milliliters, or 1,000 milliliters over 1 liter, right? All those things sort of saying the same thing. Meters to inches, 1 meter equals what, 39.37 inches, and we can write that as 1 meter over 39.37 inches, or 39.37 inches over 1 meter. Now for this one, okay, for B, we could do it as a two-step too. I could say that 1 meter is equal to 100 centimeters, and then I know 2.54 centimeters is equal to 1 inch. Okay, so that's also an option, where this one would sort of almost be like a two-stepper. Like you would convert meters to centimeters and then centimeters to inches, because this is like not a super common conversion. Last one, meters to kilometers. So I know that there are 1,000 meters for every 1 kilometer. And I can write this as 1,000 meters over 1 kilometer, or 1 kilometer over 1,000 meters. Now, you may have, for this one and this one, done it a little different. You may have said something like 1 meter is equal to 1,000th of a kilometer. That works as well. Okay, this is the same thing as this. Again, I just sort of avoid the decimals. Okay, so there are the options. It looks like they use the funky one, so you don't necessarily have to two-step it. All right, so some conversion factors may be stated within a problem that applies only to that problem. So for instance, the car was traveling at 85 kilometers per hour. Anytime you all see a situation where you have 2 units and one is divided by another one, that is a conversion factor, right? And it's specifically a conversion factor for this problem. So I know that in 85 kilometers, I will travel 1 hour, or I will have traveled 1 hour. I know that if I've traveled 1 hour, I've gone 85 kilometers. I can write it like this. I can write it like this. We can also use it in the medical field with like dosages and pills and things like that. So 1 tablet contains 500 milligrams of vitamin C. So 1 tablet is equal to 500 milligrams, or you can write it like this, 500 milligrams over 1 tablet, or 1 tablet over 500 milligrams. And those conversion factors become useful because let's say that somebody needs 750 milligrams. We can start to see, hey, we need 1.5 tablets for that person, so we'll have to cut a tablet in half. Equalities stated within dosage problems for medications can also be written as conversion factors. So Keflex, which is an antibiotic for respiratory and ear infections, is available in 250 milligram capsules. So we can say that we have 1 capsule equals 250 milligrams. We can write it like this, or we can write it like this, right? 3 options. The 250 milligram is a measured amount. So in this one, if we're using this, we would only be able to honor the 2 sig figs. The one capsule is exact because it's a discrete thing that we're counting. Percentages can also be used as conversion factors. So what is a percent? A percent or a percentage is per 100. So you're finding a ratio and then you're comparing it to like how it would behave if there was 100 of those. So a person might have 18% body fat by mass. The thickness of the skin fold at the abdomen is used to determine this body fat, right? I don't know if, I don't think they do that anymore in school, but I remember when I was in middle school and high school, they would do that to you. It was quite embarrassing. But what this is saying is that there's a couple different ways we can write it. So if we have 18% body fat, percent means per 100. So 18 kilograms of body fat for every 100 kilograms of body mass. Another way you could say it is 18, instead of kilograms, we could convert it and say 18 pounds of body fat for every 100 pounds of body mass, all right? And then again, we can put it into a conversion factor here. So I want you to write the equality and its corresponding conversion factors for salmon. Salmon contains 1.9% omega-3 fatty acids. So omega-3 fatty acids, super healthy. That's why, you know, if you can get a lot of salmon in your diet and fish in your diet, it gives you healthy fats. But figure out a conversion factor from that percentage. All right, so let's take a look at this. So 1.9% omega-3 fatty acids. So what that's saying is that, you know, if you have 100 grams of this fish, 1.9 or grams of it should be the omega-3 fatty acid. So 100 grams of salmon will yield 1.9 grams of omega-3 fatty acids. Two different ways of writing it as a conversion factor. You can put the 100 grams on top and the 1.9, or the 100 on the bottom and the 1.9 on top. Again, we'll talk about when to use each one in just a sec. All right, oh my goodness, more of these. Okay, I'm just gonna go through this real quick. So meters to centimeters. So if we wanna write a conversion factor, one could be 1 meter over 100 centimeters, right? Or 100 centimeters for every 1 meter. Jewelry that contains 18% gold. Okay, so 18 grams of gold for every 100 grams of the jewelry. Or we can, again, flip-flop that. 1 gallon of gas is $3.40. So we could say 1 gallon of gas, just one S, gas, for $3.40. Or again, we can flip-flop it and put the $3.40 over the 1 gallon. All of those are conversion factors. There we go. Okay. So why do we want to have conversion factors? Why do we need to use these? How do you know to use grams for salmon? You could have used kilograms. Yeah, that's a good question. With the percentage, you have the ability to write the unit you want to use. So if you wanted to use pounds, you could have used pounds, or if the problem was asking for pounds, you could have used it as pounds. So going back to this guy here, fair game would be 100 pounds of salmon will yield 1.9 pounds of omega-3. Okay, that's also useful or usable. Instead of gram, you could have put kilogram on both sides. The ratio stays the same. The only thing you need to do is make sure that the unit here and the unit here are the same unit. Why did they default to gram? It's just kind of a good place to default to in chemistry because we use gram. It's our base unit for mass, all right? But you could switch that out. All right, so problem solving using unit conversions. So state the given and needed quantities, write a plan to convert the given unit to the needed unit, state the equalities and conversion factors you're going to use, set up the problem, and cancel the units accordingly. So this is pretty much something called dimensional analysis, which is just a fancy way of going from one unit to another. So let's say, let's write a problem out. Let's say the given information is that you've got 14 centimeters, and I want to find how many inches that is. All right. So first thing you do is state the given and needed quantities. This isn't written in Word format, a word problem format. This is just given to you already at step 1, so we can kind of skip that. The next thing is to write a plan to convert the given units to the needed units. So I want to go from centimeters into inches, right? That's my end goal, is to go from centimeters into inches. State the equalities and or the conversion factors. Do we know the relationship between centimeters and inches? Yeah, we saw it a couple slides back. 1 inch will equal 2.54 centimeters. Okay, that's the conversion factor. Set up the problem so that units cancel. So this thing here, let me see if it's on the next slide. No, I don't see it on there. Okay, so I'm going to write this thing. This is sort of a skeletal structure for all conversion factor problems. So you can say given units times this thing right here is going to be our conversion factor. And I'm always going to write it in a way where the given units go on the bottom. And the desired, or where I'm headed, sit on the top. Okay, and then at the end of this, it will equal my desired units. All right, so given units times your conversion factor written in such a way that the given units sit on the bottom, desired units sit on the top. What happens to given units? They will end up canceling each other out, and we end up with our desired units. That is always, always, always going to be your setup for converting. So let's try that with this simple problem on the left here, all right? So I start with my given units. So my given information is 14 centimeters. So I'm going to write 14 centimeters. And then instead of thinking, oh, do I need to multiply? Do I need to divide? What do I need to do? Just set it up in dimensional analysis and let that tell you what to do. So I'm going to multiply it by my conversion factor. Here is the conversion factor. Now, when writing it, I want whatever my given unit is to be on the bottom or opposite the fraction bar here, because then they will cancel. So that means given unit underneath, I'm going to put the centimeter component on the bottom. Make sure you keep the 2.54 value with the centimeter. And I'm going to put the 1 inch on the top. Because what that does is centimeter and centimeter will cancel, and we'll be left with just a unit of inch. Then we plug this into our calculator. So what we do is anything that's sitting on top gets multiplied, anything that's sitting on the bottom will get divided. So in this case, I'm going to take 14 and multiply it by 1, which is just 14, right? And then I'm going to divide it by that 2.54. So 14 divided by 2.54 ends up with a long decimal. Your calculator should pop it out like 5.511811102. Well, my given information is 2 significant figures. Again, don't use the conversion factor to limit your sig figs, use the given. So if we get 2, that means 5.5 inches. Beautiful. So we were just able to convert from 14 centimeters into inches. And we set it up so that we were able to cancel. Now this may seem like a lot of work for what might seem like a really simple problem. Get in the habit of setting it up because the problems will get more involved as we move on. So guide to problem solving, what does this want to tell me? So to problem solving using conversion factors. So the process of problem solving in chemistry often requires 1 or more conversion factors to change a given unit to the needed unit. Yeah, so a lot of what Gen Chem 1 is really just conversion factors. It's doing that process over and over again. So in order to solve it correctly, you need to know where you're started. You need to know your given units, and then you need to connect how are the units needed, and you need to connect how the given units come together with the units desired. And that happens through your conversion factor. So steps for solving problems that contain unit conversions include state the given, write a plan, state the equalities, and then the last one I'm assuming is check. So let's do this one here. If a person weighs 164 pounds, what is the body mass in kilograms? And we're going to use this here. 1 kilogram is equal to 2.20 pounds. All right, so I'll write that on this page. So we know 1 kilogram is equal to 2.20 lbs. So I want you to try and set that up in dimensional analysis. Write your given information, what you're trying to find, maybe draw a little flow chart to help you get from one to the other, and then execute it. Just another 30 seconds to try and finish that up and talk about it. Okay, so when I'm working on word problems, or like, I mean, I guess I don't really work on them so much anymore, but when I was in school and I would work on word problems, I would always like draw and write all over everything just to help me. So I would say if a person weighs 160, so I'd like circle this thing, you know, I'd see what, I'd put like a little question mark or something to remind me, okay, that's what it's asking. It's asking me kilograms. Because I think for some students, the hardest part is just going from this into what's given and what you're trying to find. And then the dimensional analysis part is actually easy for them, but they just don't know how to pull the right information out. So, you know, if it helps you to draw all over stuff, do it. So we have a problem where we're given a weight of 164 pounds. So I'm gonna over here, I'm gonna write given 164 pounds. We wanna find kilograms. So I want to go from pounds to kilograms. So I need a conversion factor for it. I kind of helped you guys out and gave it to you already. Not every problem is going to have the conversion factor stuck in there. Now, during a test, in a traditional format, you know, some of these conversion factors you guys would have to have had memorized because you guys are going to be taking the exams online. You can reference your notes for conversion factors, okay? I guess it's the least we can do with a global pandemic is allow you guys to reference conversion factors, but you do want to be able to use them, okay? So make sure you know how to get this information pretty easily, because if you only have an hour and 15 minutes, you don't want to be spending like all your time trying to search for that. All right, so let's clear this and we'll just kind of step through their slides. So we've got one conversion, or we've got our conversion factor here, the way I had it written, and then they wrote it in these two different ways. Now, we start with our given information on our flow chart or our dimensional analysis. So we have 164 pounds. Now, I want to use, I always have to move stuff around. If this is pounds, this is my given unit. Right? So my given unit needs to be on the bottom. So I'm going to use this one instead of this one. This one doesn't apply for the problem. So if I use it where pounds go on the bottom, it cancels and cancels. Kilogram will go on the top. We end up with 74.5 kilograms. We get to use 3 sig figs here. So what I don't want to see is 164 pounds. And sort of haphazardly, you're like, oh, well, I'm just going to use, you know, you're not even really thinking about it, but you end up using the first one. So 2.20 pounds over 1 kilogram. And if you're not writing your workout while you're working on an exam or homework, sometimes this can happen. So instead of taking this and dividing it by 2.20, you take the number and you accidentally multiply it by 2.20. That is not going to work. Why? Because now my units aren't canceling. Instead, these are the units I'm getting. I'm getting pounds squared per kilogram. That's a weird unit. That's not what we want, okay? So this is a good way to check and make sure that you've set it up correctly as you go, okay, now I'm going to cancel and wait, I can't cancel. Oh crap, I gotta flip these. Then I'll be able to cancel. It's a nice way to check yourself. So let's do this one. A rattlesnake is 2.44 meters long. How many centimeters long is that snake? And there are actually 2 ways that you can do this, and I'll show you both ways because this is asking you to convert within the metric system. So if you like King Henry, you can also use King Henry. And I'll show you both. Hello, sorry. Sorry, I was talking to myself there. Can we work on some mastering chemistry? I have trouble with those. If you have one specifically that was in the mastering chemistry that was giving you some trouble, let me know what it is, and then we can try and work on it. Because the mastering chemistry does tend to be a little bit more challenging, I think, than what we see either in lecture, lab, or exams. It's just kind of a challenging program. It always is, even for 092 and 151. But if you have a specific one, David, let me know. And then, yeah, we can totally work on it. Right now, we're sort of starting simple. So if you want to throw that in there, David, you can. I'll go through this one here. So this problem, two ways to solve it. Rattlesnake is so given that the snake is 2.44 meters, and I want to find centimeters. So one way to do this is in dimensional analysis. So I know 1 meter is equal to 100 centimeters. All right, 2.44 meters, that's where I start. I use my conversion factor. I put meter on the bottom, centimeter on top. Then I add the 100 and the 1, the meter will cancel, and we end up with what, 244 centimeters. Now, if you remember, King Henry died before drinking chocolate milk. We're starting at the meter, which is our example of a base unit, and we want to go to centimeter. So we just take 2 hops, 2.44, decimal is here, 2 hops, puts the decimal here, 244 centimeters. Okay. So either one of those works. What do you guys like better? You like 1 or 2? 1 or 2? 1, 2? Some people like 1, some people like 2. Yeah, so you do you. Do what works for you, okay? Get you the right answer. King Henry, 2 is way easier. Okay, so we've got our King Henry people and we've got our dimensional analysis people. That's how it goes. David, iron has a density of 7.86 grams per centimeter cube. Calculate the volume. We will get into density in a little bit. We haven't talked about density yet, so hopefully once we talk about density, that'll make a little more sense. And we can go back to that problem, David, once we move into the density section. Did we solve this? Yeah, we solved it. We did it. Okay. 244 centimeters. So do know that in problem solving, 2 or more conversion factors are often needed to complete it. So sometimes we've got to do we have to like sort of leapfrog our units. So each factor is arranged in such a way to cancel the unit, just the unit that came before it, to get into the new unit setup. So I'm going to give us an example using time. I always feel like students can get that pretty easily. So let's go to our board here. By King Henry. All right, so I'm going to text it. Okay. How many seconds are in 8.09 days? So this is a multi-step problem. I'm going to give you about just 2 minutes to try and set it up using dimensional analysis, and then I'll go through and kind of help you refine it, okay? And you may be able to solve this without doing dimensional analysis. Again, the process though is to try and get it into dimensional analysis. So this is a multi-stepper. Okay, so with this problem, here's my starting, here's my ending. So I know given wise, I'm presented a value in days, and I'm trying to find seconds. Okay. I want to know what seconds are. So I'm going to make a little flow chart over here. I would say going from days into hour, and then hour into minute, and then minute into second. That would sort of be my plan of attack there. You could be one of those people that has like a bunch of, I don't want to say useless information, but a lot of information in your head, and you know how many seconds are in a day. If you know that, you can convert it directly. But I don't, but I do know these simple ones. So what I'm going to do is chain it together. So when you're stitching these together, these multi-step, the first step is to go from days into hours. I'm not going to worry about minutes and seconds yet. I'm just going to go from days to hours. So start it the same way with your given information. Use a conversion factor that relates days and hours. Day is on top, so day needs to be on bottom down here. Hour needs to be on top, and then you just fill the relationship in, right? So one day has 24 hours in it. Then if I'm going into minutes, hour is, so the next step is to go from hours to minutes. So we can ignore day, we can ignore second. We're just looking at this step here. Now I'm going to tell you, some people like to solve for hour and then restart again and solve for minute and then equal it out and then start for second. I'm just going to stitch mine together into one big chain here. Okay. So I'm going to multiply by my next conversion factor, which is the hour to minute one. So hour goes on the bottom. Minute will go on the top, and I know for every 1 hour I have 60 minutes. Then I'm going to put one more conversion factor. So this is sort of this step 1, this is your step 2, this is my step 3 conversion factor here. Minute is there, so I'm going to put minute on the bottom and I'm going to put second on the top. For every 1 minute I get 60 seconds. And then I can go through and cancel all my units and make sure I end up with just seconds. So there's day and there's day. Bye. Hour and hour. Bye. Minute and minute. See ya. We are just left with seconds. We like that. So, excuse me, my allergies are bothering me today. 8.09 times 24 times 60 times 60. Okay, so I got 68, nope, that was a 9. 698,976 seconds. The last thing we want to do is round to sig figs. Remember, these are definitions. This conversion factor, these are exact ratios or relationships, so they don't limit it. So we would go with 3 sig figs. So 3 sig figs would mean we keep the 6, we keep the 9, we keep the 8. The 9 tells the 8 to round up. So 6, 9, 9, 0, 0, 0 seconds. And just for fun, why don't we write it in scientific notation for practice? There's the decimal. I need to move it over there to get it in scientific notation. 1, 2, 3, 4, 5 hops, 6.99 times 10 to the, this is a big number, positive 5. Cool. So that's a multi-step problem. No, we definitely don't want to do that. Okay. There we go. Ooh, my nose is itchy. Ooh, ooh, ooh. All right, so here a doctor's order prescribed a dosage of 0.15 milligrams of Synthroid. If tablets are in stock contain 75 micrograms of Synthroid, how many tablets are required to provide the prescribed medication? So this is a multi-step problem. We know how many milligrams we need. We need to convert it into micrograms, and then from micrograms, we can use the relationship of 75 micrograms for 1 tablet to figure out how many tablets we need. So we know 1 milligram is equal to 1,000 micrograms, and we know 1 tablet is equal to 75 micrograms. This conversion factor is given to us specifically in the problem. So we start with our given dosage, 0.150 milligrams. I use the first step to get into micrograms. So I'm just going to convert milligrams into micrograms. I put the milligram on the bottom and the microgram on the top. I want this thing. I don't want these. So we cancel, cancel. Then I multiply it by my microgram to tablet ratio. So I know for every 75 micrograms, I get equal to 1 tablet. This goes on the bottom so that it cancels here. Cancel, cancel. And when we plug this into our calculator, if we take our original number, multiply it by 1,000 and then divide it by 75, it works out to 2 tablets. the unit of tablet being the only thing that's left around. How many minutes are in 1.4 days? This is sort of similar to what we did. It just didn't go quite as far. So if we know we have 1.4 days, 24 hours in 1 day, 60 minutes in 1 hour, we get this. All right, this one is all right, so if your pace on a treadmill is 65 meters per minute, how many minutes will it take you to walk a distance of 7.5 kilometers? Try this one out. Sorry. All right, I do want to make a note because we didn't get quite as far as I wanted to, but it's okay. We've got more than enough time. So the homework assignment that is due on Sunday, I just moved it to Thursday for next week because we won't have lectured on density yet. So David, your question, we're not gonna like have gone over that. So I don't want you guys to have to do homework that we haven't gone over yet, okay? So know that you've got a little extra time for the homework. Let's just pop into this question real quick before it's time to go. Lab 3, because there's questions on density. Let's move, yeah, we'll move lab 3 to the following weekend, the following Sunday, okay? So I will change that today at some point. All right, so you don't need to submit lab 3 until the following week, but the other lab is also due. All right, so you'll just have double up on labs the following week. If you want to submit the density lab this Sunday, you're more than welcome to if you feel comfortable with density. But yeah, we won't do that till next time. Okay, so looking at this problem here, if you pace on a treadmill at 65 meters per minute, how many minutes will it take for you to walk a distance of 7.5 kilometers? All right, so in this problem, we're in kilometers here. This is meters per minute. So this is a conversion factor, meters per minute. So I'm gonna, but this is in kilometers. I need these to be in the same unit. So the first thing I'm gonna do is take my kilometer value, I'm gonna convert it into meters. And then using this conversion factor, I can get it into minutes. So I know that for every 1 kilometer, I have 1,000 meters. And then for every 65 meters, I've gone 1 minute. So we take our 7.5 kilometers, we multiply it by the kilometer to meter factor to get it into meters. And then from there, I get to use this thing as a conversion factor, which is, I think, the part that gives people trouble is realizing this is a conversion factor. So 65, let me put my annotate on. 65 meters per minute is the same thing as 65 meters equal to 1 minute, or this, or this. So from here, we've got our 7.5, we've converted it into meters, and now I use this thing, because every 65 meters will yield 1 minute, and we get 120 minutes. So we'll spend a little bit more time. Again, we don't have lecture on Monday, but we do on Wednesday. We'll spend a little bit more time working on conversion factor stuff, and then we'll do density. So we'll finish the chapter and then we'll move into the following chapter. All right. So one of the labs will be due Sunday. The second lab, the density lab, I'll switch over to the following Sunday, and then homework will be due on Thursday. If you have questions outside of that, stay around and I can talk to you one-on-one. I'll throw you in a waiting room and then chit chat with each of you individually. Do I want pre-labs submitted with labs? Yes, pre-labs need to be submitted unless it explicitly tells you to omit the pre-lab. All right, so be doing the pre-lab questions unless the directions say, don't do pre-lab. Great. Awesome. Well, you guys have a really good rest of your week. I will be around for some help if you need it tomorrow for lab stuff. Otherwise, I will see you a week from today. Thanks. Bye. Is your YouTube up for Monday? Not yet. I will put those up usually by Wednesday or Thursday. I have to like do a little bit of editing. I try and clip the front and the end so it isn't, sometimes there's just like 15 minutes of waiting. So you don't want that. But I should get it up in the next day or so. Okay, let's stop sharing.